To create a more complex Sankey diagram with 10 inputs, 21 processes, and 5 outputs in the context of an AI/ML workflow, we'll structure the nodes and links to simulate a flow commonly seen in AI/ML pipelines. Here's an example. Pradeep K. Suri. Author, researcher, and AI/ML architect. 1 inputs, representing raw data sources, example datasets. 2 processes, representing various stages of data pre-processing, feature engineering, model training, evaluation, and deployment. 3 outputs, final outputs such as predictions, insights, or models in production. Explanation. Nodes, we have labeled 10 input nodes, 21 process nodes, and 5 output nodes. Inputs, data sources representing different data sets. Processes, various steps common in AI/ML pipelines, such as data cleaning, feature engineering, model training, evaluation, and deployment. Outputs, final outputs of the pipeline, including predictions, deployed models, insights, reports, and feedback loops. Links. Each source and target pair specifies a flow from one node to another. Values represent the weight or quantity flowing from each source to each target, which could represent the volume of data or importance of each connection. Colors. Inputs are colored in a specific shade, blue, processes in another shade, orange-red, and outputs in a different shade, green, making each stage distinguishable. This code will render a Sankey diagram with a dark background and colors highlighting each node category, representing an AI/ML pipeline's flow from raw data sources through various processes to the final outputs. In the complex Sankey diagram with 10 inputs, 21 processes, and 5 outputs in the context of an AI/ML workflow, we'll structure the nodes and links to simulate a flow commonly seen in AI/ML pipelines. Here's an example. 1 inputs, representing raw data sources, example datasets. 2 processes, representing various stages of data pre-processing, feature engineering, model training, evaluation, and deployment. 3 outputs, final outputs such as predictions, insights, or models in production. The Sankey diagram code above can be used as a template to visualize other workflows or processes that follow a similar input-process-output structure. Here's how you can adapt it for different purposes. 1. Customize node labels and colors. Labels, replace the existing labels list with new names for inputs, processes, and outputs that suit use case. For example, if you're working on a manufacturing process, you might have inputs like raw materials, processes like assembly, and outputs like finished goods. Colors, adjust the colors list to use distinct colors that represent different categories or stages in specific process. 2. Define new connections between nodes. Source and target, update the source and target lists to represent the new connections between nodes. Each source-target pair should reflect the flow from one stage to another in customized workflow. Values, modify the values list to reflect the magnitude or importance of each connection in specific scenario, example volume, importance, or cost. 3. Update layout for different backgrounds. You can change the plot_color, paper_color, and font_color to match a different color scheme if needed. This is especially useful if you plan to integrate the diagram into presentations or reports with a specific theme. 4. Adjust node and link appearance. Node thickness, you can adjust thickness in the node dictionary to make nodes thicker or thinner based on how dense or sparse you want the diagram to look. Pad, change pad to control the space between nodes, which can help to make crowded diagrams easier to read. Summary of workflow representation. 1. Inputs, 10 data sources represent the starting point for the AI/ML pipeline. 2 processes, the data flows through various processing stages. For example, raw data is cleaned and normalized. Feature selection and engineering prepare the data for modeling. Model training, tuning, and evaluation occur in stages. After training, the model undergoes further optimization and deployment. 3 outputs. Finally, the pipeline results in various outputs. Prediction results, the model's predictions. Deployed model, a model placed in production. Model insights, insights from model analysis. Reports, documentation and reporting. Feedback loop, data from users or monitoring, used for retraining if needed. This Sankey diagram provides a visual overview of an AI/ML pipeline, helping to understand data flow through different processes to final outputs. How to use as a template. 1. Copy the entire code structure as a starting point. 2. Make changes as described above to fit the new purpose. 3. Run the code in a Python environment that supports Plotly, like Jupyter Notebook or Visual Studio Code, to visualize the customized Sankey diagram. Using this template, you can easily adapt the Sankey diagram to visualize data flows for various scenarios, whether in business processes, engineering pipelines, customer journeys, or supply chains. This Sankey diagram represents a typical AI/ML workflow, illustrating how data moves through different stages in a machine learning pipeline. Here's a breakdown of each part of the workflow in detail. 1. Data sources, left side. The workflow begins with multiple data sources, labeled as data source 1 through data source 10. Each source is represented by a blue rectangle, signifying a unique source of raw data. These could be databases, data warehouses, APIs, or any other origin for data that will be processed. The various data sources feed into the next stage of the workflow, data cleaning. 2. Data cleaning. This stage is where raw data from each source is processed to remove inconsistencies, handle missing values, and filter out irrelevant information. Data cleaning is crucial for ensuring that the data quality is suitable for model training. In the diagram, the flows from each data source converge into a single node labeled data cleaning, red box, highlighting that all incoming data must be standardized and cleaned before further processing. 3. Normalization. Once data is cleaned, it flows into the normalization step. This process scales or adjusts data features to ensure consistency across the dataset, which is especially important for models sensitive to variations in data ranges. Normalization helps make the data uniform and ensures that all features contribute equally to the model's learning process. 4. Feature engineering and feature selection. After normalization, data is split into 2 parallel flows. Feature engineering. This involves creating new features or modifying existing ones to better represent the underlying patterns in the data. Feature selection. This step identifies the most relevant features for the model, reducing dimensionality and focusing on variables that will improve model accuracy and efficiency. Both processes refine the data, ensuring that only useful information is retained for training. 5. Train test split. This stage divides the data into training and testing sets. Training data is used to train the model, while testing data evaluates its performance on unseen data, giving an estimate of how well the model might generalize. 6. Model training. The diagram then shows 2 separate paths for model training, labeled Model Training 1 and Model Training 2. This indicates that multiple models may be trained in parallel to compare performance and select the best one. Different algorithms or versions of the same model can be tested to find the optimal configuration. 7. Data augmentation. Between the 2 model training stages, there is a data augmentation step. This technique increases the dataset size by generating new examples through transformations such as rotations, flips, or scaling, commonly used in image processing. Augmentation helps improve model robustness. 8. Cross-validation. Cross-validation, represented by a separate node, is a technique used to assess the model's performance across different subsets of data. This ensures that the model's evaluation is consistent and not biased by any specific data split. 9. Evaluation metrics. Once the model is trained, it is evaluated using various metrics, example accuracy, precision, recall, F1 score, to assess its performance on different criteria. This provides insight into the model's strengths and weaknesses. 10. Model optimization. In this stage, model parameters are fine-tuned to improve performance. Techniques like hyperparameter tuning or optimization algorithms are used to find the most effective settings for the model. 11. Ensemble learning. Ensemble learning combines multiple models to improve prediction accuracy and robustness. By aggregating predictions from several models, this approach often yields better results than any individual model. 12. Hyperparameter tuning/data monitoring. This step involves monitoring the data and tuning hyperparameters to optimize the model further. This step is essential for maintaining performance and detecting potential issues in production environments. 13. Pipeline integration and model deployment. The final stages involve integrating the entire pipeline and deploying the model to a production environment. This makes the model available for real-world applications where it can interact with new data and provide predictions or insights. Each connection between the nodes in the diagram represents a flow of data or a process. The Sankey diagram's thickness indicates the volume or importance of the data flowing from one stage to the next, emphasizing the path that data follows through the entire AI/ML workflow. The example from the template. The diagram illustrates the garment export process from India through an AI/ML model, following the stages from raw material suppliers to various export destinations. Here's a detailed breakdown of each stage and flow. 1. Raw material suppliers. Cotton suppliers, represented in yellow on the left side, they provide cotton, which is a primary raw material in the garment production process. Fabric suppliers, represented in orange, they supply pre-made fabric that may be directly used in garment production. Thread suppliers, represented in red, they provide thread necessary for stitching and sewing. 2. Manufacturing process stages. Spinning, cotton from suppliers is first processed in the spinning stage, shown in blue. Spinning transforms raw cotton into yarn or thread, which will be used in the weaving process. Weaving, this process is also shown in blue and follows spinning. Weaving converts yarn into fabric, which is essential for garment production. This fabric may then move directly into dyeing or other stages. Dyeing, represented in teal, dyeing adds color to the fabric, which enhances the garment's appearance and can be customized based on market requirements. Cutting, the dyed and woven fabrics move to the cutting stage, represented in green. Here, fabrics are cut into specific shapes and sizes based on garment designs. Stitching, shown in light green, stitching assembles the cut fabric pieces into final garment forms. This stage combines fabric, thread, and other materials. Quality control, represented in dark red, the quality control, QC, stage ensures that the final products meet quality standards. Only approved garments proceed to export destinations. 3. Export destinations. The final processed garments are exported to various regions, represented on the right side. USA, represented in pink, a major export market for Indian garments. Europe, another key market for Indian garment exports. Middle East, shown without a specific color, indicating its role as an export destination for Indian textiles. Asia, this includes exports within the Asian continent. Africa, the final region in the export destinations, showing that Indian garments also reach African markets. Flow paths and connections. The width of the flows between stages in the Sankey diagram represents the quantity or importance of materials or products moving from one stage to the next. Each stage, spinning, weaving, dyeing, etc., receives inputs from earlier stages or raw material suppliers, and outputs are directed to subsequent manufacturing processes or directly to export markets. This flow provides a clear view of how raw materials are processed and assembled into garments that are exported to various international markets. Summary. This Sankey diagram provides an end-to-end view of the garment manufacturing and export process from India. Starting from raw materials provided by suppliers, each production stage adds value to the product, ultimately leading to finished garments that are shipped to different parts of the world. The visual thickness emphasizes the flow volumes, highlighting the stages with the largest material or product throughput. Here's a structured list of reports and graphs suited for different management levels in an organization, focusing on the needs of top management, middle management, and operational level. Each management level has specific requirements for information granularity, visualization, and focus, so the reports and graphs listed here are tailored accordingly. 1. Top management, executive level. Focus, high-level insights, trends, strategic decision-making, and performance tracking against organizational goals. Reports. Executive Summary Report provides an overview of key performance indicators, KPIs, and progress towards strategic objectives. Financial Summary Report summarizes profit and loss, revenue, expenses, and overall financial health. Market Position Report analyzes market share, competition, and customer segments. Risk Management Report identifies major risks and their potential impact on the organization. Sustainability and ESG, Environmental, Social, and Governance Report covers the organization's impact and compliance with sustainability goals. Graphs. Revenue and profit trends, line or area charts showing monthly, quarterly, or yearly revenue and profit trends. Growth rate comparison, bar chart comparing growth rates against industry benchmarks. Market share, pie chart showing market share across different regions or segments. Risk heat map identifying risk levels across various business areas. Sustainability KPI dashboard, multi-metric dashboard showing ESG performance indicators. 2. Middle management, department heads and functional managers. Focus, departmental performance, process improvement, and operational efficiency. Reports. Departmental Performance Report provides details on each department's performance, highlighting efficiency, resource allocation, and target achievement. Project Status Report tracks the status, milestones, budget, and timeline of key projects. Sales and Marketing Report breaks down sales performance by region, product line, or sales team. Inventory and Supply Chain Report monitors inventory levels, supply chain efficiency, and order fulfillment rates. Customer Satisfaction and Feedback Report highlights customer feedback, satisfaction scores, and service quality. Graphs. KPI Dashboard, multiple KPIs visualized for each department, including sales, productivity, and quality metrics. Project Timeline Gantt Chart, visual representation of project timelines, milestones, and resource allocation. Inventory Turnover Ratio, line chart showing how efficiently inventory is being managed over time. Sales Funnel, Funnel chart breaking down the sales process stages, example leads, qualified prospects, conversions. Customer satisfaction trends, line chart tracking customer satisfaction scores over time. 3. Operational level, team leads and supervisors. Focus, daily operations, task management, and process level metrics. Reports. Daily/weekly activity report, summary of completed tasks, outstanding issues, and daily/weekly accomplishments. Quality control report, tracks defect rates, quality inspection results, and compliance with quality standards. Workforce productivity report, measures productivity and efficiency on the shop floor or among service teams. Inventory and order fulfillment report, monitors stock levels, reorder points, and order fulfillment accuracy. Maintenance and downtime report, tracks equipment uptime, maintenance schedules, and downtime incidents. Graphs. Task completion chart, bar chart showing tasks completed versus outstanding tasks for the week. Defect rate trend, line or bar chart tracking the defect rate in production over time. Employee productivity histogram, histogram showing productivity distribution across team members. Order fulfillment status, stacked bar chart showing on time versus delayed orders. Downtime analysis, pie chart or bar chart showing causes of downtime, example maintenance, shortage, delays. Additional considerations. Dashboards, for all levels, customizable dashboards can combine multiple KPIs and charts to provide a real-time overview. For example, Executive Dashboard for top management with financials, growth metrics, and risk indicators. Operations Dashboard for middle management with project status, inventory levels, and sales metrics. Daily Operational Dashboard for team leads, showing task completion, quality control data, and equipment status. Automated Reporting, automated, regularly updated reports can be beneficial for all levels, providing timely data without manual intervention. Alerts and notifications, adding alerts based on threshold levels, example low inventory, delayed project milestones, can support all levels, especially operational and middle management. This structure helps to ensure that each management level has the right information at the right time, enabling informed decision-making that aligns with organizational goals. Explanation of the code. 1. Data preparation. We define sample data for KPIs such as revenue, profit, customer satisfaction, and employee productivity over a period of 5 months. 2. Subplots layout. We use make_subplots from Plotly to create a 2x2 grid layout. The top row displays bar charts for revenue and profit, while the bottom row shows gauges for customer satisfaction and employee productivity. 3. Adding revenue and profit bar charts. Each bar chart represents monthly data for revenue and profit. We use different colors for each metric for visual differentiation. 4. Adding gauges for satisfaction and productivity. Go.indicator is used to create gauges for customer satisfaction and employee productivity. These indicators show the latest value in each metric's data list. The gauge dictionary allows customizing the range and color of each gauge. 5. Layout customization. The layout includes a title, and template equals Plotly_dark is applied for a dark background. The figure's height and width are adjusted for optimal display. Output. Revenue and profit bar charts display monthly performance, allowing quick comparison. Customer satisfaction and employee productivity gauges show the most recent scores and progress toward a target, 100 in this case. This program provides a straightforward way to monitor KPIs in a single dashboard, ideal for an executive summary report. You can modify this example to include additional KPIs, adjust the data, or change the visualizations based on specific reporting needs. Example: Executive Summary Report, AI/ML Model. The Executive Summary Report, AI/ML Model, dashboard displays key performance metrics for a business over a 5-month period, January to May. This dashboard consists of 4 main sections, each representing a specific metric that provides insights into the business's revenue, profit, customer satisfaction, and employee productivity. 1. Monthly revenue, top left. Description: this bar chart shows the monthly revenue from January to May. Data: each bar represents revenue for 1 month, with values increasing over the months. Analysis: January starts with a revenue of around 100 units. There's a steady increase each month, reaching a high of approximately 140 plus units by May. The trend suggests consistent growth in revenue, indicating positive business performance. 2. Monthly profit, top right. Description: this bar chart displays the monthly profit from January to May. Data: profit figures are shown on the y-axis, with each bar representing a month. Analysis: starting in January, the profit is around 20 units. There's a steady increase each month, peaking at over 40 units in May. This consistent rise in profit aligns with the revenue growth, suggesting efficient cost management or increased profitability alongside revenue growth. 3. Customer satisfaction, bottom left. Description: this gauge chart indicates customer satisfaction as a score out of 100. Data: the current satisfaction score is 92, shown prominently in the center of the gauge. Analysis: a score of 92 is very high, indicating that customers are highly satisfied. The orange gauge arc, covering a broad range from 20 to 100, further emphasizes strong customer approval. High customer satisfaction is a positive sign, suggesting that the business's products or services are meeting or exceeding customer expectations. 4. Employee productivity, bottom right. Description: this gauge chart represents employee productivity as a score out of 100. Data: the productivity score is currently at 85, displayed in the center of the gauge. Analysis: a score of 85 reflects a high level of employee productivity. The purple arc spans a range from 20 to 100, emphasizing that productivity is within an optimal range. High employee productivity often correlates with increased output and efficiency, which may contribute to the observed growth in revenue and profit. Summary: the dashboard offers a comprehensive snapshot of business performance, highlighting positive financial growth. Both revenue and profit are on an upward trajectory, reflecting financial to achieve. High customer satisfaction, a score of 92 suggests strong customer loyalty and approval. Strong employee productivity, with a productivity score of 85, the workforce is performing efficiently, supporting business goals. These metrics together indicate a well-performing business with satisfied customers and productive employees, suggesting that the company is likely achieving sustainable growth. Thank you.